Hi. So in our first video, we determined that the molar mass of carbon dioxide is 44.01. Now, depending on what we're looking at, that could be 44.01 grams or 44.01 atomic mass units. Now, since we're talking about moles, it's going to be grams. So we had discussed this, and molar mass CO2 44.01. Since I'm going to be looking at mass, I'm going to put grams there. So 44.01 grams. So what does that mean, and why is it important that this amount of grams equals 1 mole? Well, let's look here. So here we have the chemical equation for the combustion of methane. We have methane plus 2 oxygen yields carbon dioxide and water. This is what happens when you light the burner on your stove. The methane burns in the presence of oxygen after we put a little spark to it to ignite it, and it forms carbon dioxide and water, both in the gas form. Whoops, I forgot to put a gas by water. There you go. So it's steam, it's not liquid. There you go. And so you can write it out this way. 1 mole of methane plus 2 moles of oxygen gas yields 1 mole of carbon dioxide and 2 moles of water. And so it's not true, we can't just substitute grams in there, okay? Because it's not 1 gram of methane yields 2 grams of oxygen. That doesn't work. So it's important that we realize that moles relate to things that are not the same, that have different masses to each other, because a mole is a mole is a mole. And so we can say that's comparing on a fair plane when we switch everything to moles. So that's why one of the primary skills you need to have in chemistry is to be able to switch from grams to moles. Okay, so let's look here at this really simple little problem. Let's say that I have 50 grams of carbon dioxide. I want to know how many moles that is. Now, this is a 3-part equation. What's a relationship? The equation's down here. So this is a 3-part relationship. 1 mole of anything equals the molar mass, which we find from the periodic table, equals Avogadro's number. Here, I'll write that in. So this is Avogadro's number. You can make this for anything. 1 mole of water equals the molar mass of water equals 6.02 times 10 to the 23rd molecules of water. For salt, and we'll do this in another video, but if you're doing it for something like salt that's an ionic compound, it would be 1 mole of salt equals the molar mass of salt equals 6.02 times 10 to the 23rd. The only difference would be, instead of molecules, an ionic compound, which we'll talk about later, has formula units, okay? So, but right now I'm focused on carbon dioxide, and it has 1 mole of carbon dioxide is 44.01 grams. So if I have 44.01 grams of carbon dioxide, like I have it, trapped in a cylinder or something, then I have 1 mole of it. So if I want to figure out how many moles I have that I can then go back and use in that equation that I just showed you, this guy right here, and we can then turn that carbon dioxide into methane, we can turn it into oxygen, we can turn it into water. We can do that. We're not there yet, but eventually that's what we'll be able to do. So all I have to do is set up the 50 grams that they give me, and then this is a true statement. So this is your ratio. Now I want you to look at the ratio right here. When you make this ratio, the only thing that ever comes from, the only parts that are in that ratio are from here, here, or here. And so if I start out with grams, grams will go on the bottom. Whatever you have here, boom, that goes on the bottom. Whatever I want, and I asked you that right up here, goes on top. So what you have on the bottom of the ratio, what you want goes on top. We don't use molecules because we aren't talking about molecules. Could I switch it into molecules? Sure I could. But since the problem asks for moles, I'm going to go ahead and do that right now. So I got my calculator. 50 grams divided by 44.01, and it's just going to be 1.14 grams. Now, we'll talk about sig figs later, but I wasn't really good with sig figs there. But that's how you do that one. All right, catch you later. Bye.